Okay, so today we're going to jump over 9.5. We're going to cover lesson 7, and this is properties of matrices. So the first thing we're going to learn how to do is add and subtract matrices. So the key for adding and subtracting two matrices is that the matrices must be the exact same size. So I can only add, for example, a 2 by 2 with a 2 by 2. I would not be able to add a 2 by 2 with a 3 by 3 or subtract it. So it must be identical sizes, and then all we're going to do is add the elements that are in the same spot. And I'm going to show you what I mean by that. So also the properties, the matrix addition, it can be commutative, associative, the closure property, identity, and inverse properties. So all of these properties can apply for matrix addition. And then as far as the subtraction goes, again, the matrices have to be the same size. When I subtract my matrices, I'm going to do it as like a keep flip change, just so I don't forget that I'm subtracting. And I'm going to show you what I mean by this on the next example. So here is my first example. Notice that the instructions say to find the sum if possible. So for example, if these two matrices were not the same dimensions, then my answer would be no solution. However, they're both 2 by 2, and when you name a matrix as far as give the dimensions, it's always rows by columns. So both of these matrices that are listed here, they're both 2 by 2s, so I can find the sum. So the way that I'm going to find the sum or add two matrices is I'm going to take it element by element. So I'm going to take the element that's in the first row, first column, and I'm going to add it to the element that's in the first row, first column in the other matrix. So 5 plus -4 is 1. So that's my first answer. Then I'm going to shift over to still row 1, but column 2, and add it to the same spot, so the same row 1, column 2. So -6 plus 6, and I get 0. Then I'm going to shift down to row 2. The 8 is in row 2, column 1, and I'm going to add it to the 8 that's over here in row 2, column 1, and I get 16. And then lastly, I'm going to shift over to still row 2, column 2, and add it to the row 2, column 2 over here. And I get 6. And I'm done. So for the adding and the subtracting, you're just adding the elements that are in the same. Now, for the subtraction, again, the matrices have to be the same dimensions. So for example, before I do number 2, if I gave you a matrix that was 1, 2, 3, 4, 5, 6, and for example, this is a 2 by 3, and if I asked you to add that to a 1, 2, 3, so a 3 by 1, you would say that the answer here is no solution because they are not exactly the same dimensions. So this is what I mean by having the same dimensions. Has to have exactly the same number of elements in it. All right, let's do the subtraction. So again, this one I can do. They're both 2 by 2s. So again, what I like to do for my subtraction of matrices is I'm going to keep my first matrice the same. I'm going to change the subtraction to an addition. I'm going to do a state change or a keep change flip. And then all of the signs in the second matrix, I'm going to make them all opposites. And now I'm just going to add them. Now, if that confuses you, you can go back and do -5 minus -3. But then you got to remember that negative is going to make it become positive. So now that I've already set everything up, so now it's an addition problem, I'm going to add -5 plus 3, and I get -2. And then I'm going to go back and add 6 plus -2, and I get 4. I'm going to go back and add 2 plus -5, and I get -3. And lastly, 4 plus 8, and I get 12. And I'm done. So you're just adding it element by element, and then writing the answer in the same place where both of the previous numbers were. And again, if they are not the same dimension, then you would say no solution. The next thing we're going to cover is multiplying matrices. Everybody good on the subtraction? Now, the first one is really easy. It's telling us that we're going to multiply matrices by a scalar. And sort of think of this as like a scale factor, or like if you were to enlarge a figure back in geometry. That scalar is going to be some integer that you're going to multiply the entire matrix. So basically, I'm just going to distribute the 5 to all 4 of the elements of my matrix. So my answer here, I'm going to multiply the 5 to the 2, and that's going to give me 10. And then I'm going to multiply the 5 to the -3, and that's going to give me -15. And then I'm going to multiply 5 and 0, and that will give me 0. And then I'm going to multiply 5 and 4, and that will give me 20. And I'm done. So you're basically distributing that scalar, or the number outside of the matrix, to each one of the elements of the matrix. Now for the trickier part. This is multiplying a matrix with a matrix. Now, usually, remember, multiplication is commutative. So, and what I mean by that is if I were to ask you to multiply 2 times 3, what would you get? 6. What if I ask you to multiply 3 times 2? Okay, so normally the order of when you multiply numbers, it doesn't matter. You still get the same answer. However, multiplication of matrices is not commutative. So when you're given a problem, you have to multiply it the way it's given to you. You can't rearrange the matrices. So whatever's on the left stays on the left. Whatever's on the right will stay on the right. Now, in order to multiply matrices, we have to have, they have to have the same number of columns as they do rows. So again, remember when we state the dimensions of our matrix, remember we're stating the number of rows first and the number of columns second. Now, in this one, it's easy because they're both 2 by 2s. Now, to double check if the product or the multiplication is possible, I'm going to write down what the dimensions are. And then these 2 numbers, the 2 inside numbers, must be the same. They must match. If they do not match, your answer is no solution. If they match, the resulting matrix after we multiply is going to be the outside 2 numbers, and the resulting matrix is going to be a 2 by 2. And I'm going to show you how we're going to get it to that. So when we multiply 2 matrices together, we're multiplying the rows of the first one times the columns of the second one. So we're multiplying rows times columns. I'm going to show you what this means. So the first thing I'm going to do, now my matrix C should end up being, let me go ahead and highlight this. It's supposed to be a 2 by 2. So I should get an answer to put here, an answer for here, here, and here. Okay, so the first red that I'm going to take care of is I'm going to be multiplying row 1 times column 1. So I'm going to multiply them and add them. So I'm going to do 1 times -2 plus 3 times 0. and I get -2 plus 0. So this element is -2. Then for the blue, we're still in row 1, and I'm going to multiply row 1 now times column 2, row by column. So now I'm going to multiply 1 times 7 plus 3 times 2. 7 plus 6, and I get 13. Now to get row 2, I'm going to multiply row 2 first by column 1. So -2 times -2 plus 5 times 0. 4 plus 0, and I get 4. Then the yellow, still row 2 times column 2. So -2 times 7 plus 5 times 2. -14 plus 10, and I get -4. And that is multiplying a 2 by 2 matrice with a 2 by 2. The result is a 2 row by 2 column matrice. I'm going to do another example so we can get the hang of this. So when we multiply 2 matrices together, we're multiplying rows by columns. So the rows of the first, the left, by the columns of the right side, the right matrix. We're going to do another example. Again, you should check the dimensions to make sure it's possible. So this is a 2 by 2. Another color. 2 by 2. And this one is a 2 by 1. Notice these two need to match, which they do. It's the same, so I can find the product. And my answer is going to be a 2 by 1. So again, let's do this. I'll highlight it. So again, I need to multiply row 1 times the column. So -1 times 6 plus 5 times 2. -6 plus 10, and I get 4. There's no other column to multiply row 1 by, so now I'm going to jump down to row 2 and multiply it by the same column. So now I get 7 times 6 plus 0 times 2. 42 plus 0, and my resulting matrix is 4 over 42. 4 and 42. And you're done. So again, 2 rows, 1 column. So example 6, again, this is a 2 by 3, 2 rows by 3 columns, and this is 3 rows by 1 column. Again, the 3's match, so my resulting matrice, or my answer, is going to be a 2 by 1. So again, we're going to multiply row 1 times the column, -6 times -2 plus 3 times 0 plus 5 times 3. 12 plus 0 plus 15 gives me 27. Then I'm going to do no more columns to multiply row 1 by. So now row 2 times the column. And again, 2 times -2 plus 9 times 0 plus 1 times 3. -4 plus 0 plus 3. -4 plus 3, -1. And it's a 2 by 1. 7 is going to be the same thing. Again, we're starting with a 2 rows by 3 column and a 3 row by 1. The 3's are the same. Again, my answer matrix C is going to be a 2 by 1. So again, row 1 times the column, -9 times 2 plus 2 times -1 plus 1 times 4. And then I'll shift over, row 2 times the column, 3 times 2 plus 0 times -1 plus 0 times 4. Let me do the math here. This is 6 plus 0, and I get 6. The red, -18 plus -2 plus 4 gives me -16. Again, 2 rows, 1 column. One more example. Everybody go to on number 7. Okay, example 8. Again, it's important to write down the dimensions. Again, this is a 2 row by 4 column and 2 rows by 3 columns. Notice the middle numbers don't match. This is no solution. So you can either write that or write out the words. You cannot find this product because the number of rows and the number of columns do not match. Good? All right, so your homework for this is 21 through 29 odd and then 51 through 61 odd. And this is due tomorrow. I did change the due date. Tomorrow we will go back to 9-5 and we will actually spend tomorrow and Friday practicing it. It's not a new concept. Tomorrow 9-5 we're doing substitution and elimination. You just have to be careful. Take your time, watch your signs. We're still doing the same process that we did with the linear. Okay, but instead now we're gonna have exponents. So this is your homework for 9-7. We'll do 9-5 the next 2 days and then 9-8 on Monday, and then we'll begin reviewing for your test. The test will cover all of chapter 9 and it is scheduled a week from today. That's it.